So in this problem right here, I'm giving you the graph of the original function and then graph the derivative. Keep in mind that the derivative is talking about the slope. So we need to examine this graph and take a look at the slope. So in this part, it is a horizontal line, which means that the slope is 0. So for graphing the derivative, I can say up until x is a -1, it equals 0, because a horizontal line has slope 0. So that's what the derivative would look like so far. And then if you look at this part, this is meant to be a straight line, so this is a constant slope, and it's going down, so it's negative. And the run would be 1, the rise would be 1, so the slope is a -1. So between -1 and 0, it's always equal to a -1. So down here is -1. From here to here, it's always equal to a -1. Now at a point like that where there's a little corner, the derivative does not exist. So that means I need an open circle on this, that it doesn't exist at that point, and an open circle on this. Now for this side. So this looks like the right half of a parabola, and the slope is positive because it's going up. So at this point, if the whole thing was a parabola, like this, then at this point, the derivative would equal 0. And then it would be positive, and it would be increasing and increasing. So it needs to start at 0, and it needs to be increasing. So here's 0, then it needs to be increasing. Well, if this was a parabola, then I know that the derivative is equal to 2x. So then draw a line that looks like y equals 2x. So that would be a line going up like this. And we're almost done. One other detail is, right there, that's a filled in circle, so this needs to be an open circle. And then my pretty picture is finished.